Safer Chemicals Podcast. Sound science on harmful chemicals. Hello and welcome to the Safer Chemicals Podcast. We will be speaking with Tim Bowmer, Chair of our Committee for Risk Assessment, as well as with Maria Ottati, who chairs the Committee for Socio-Economic Analysis. The two committees have just finished their first meetings of the year and will be taking a closer look at what was discussed. Before we go ahead to the topics, just a bit of background on the two committees. Both are made up of scientists nominated by EU member states and appointed by the Management Board of ECHA in their personal capacity. Both also have observers from different EU organizations representing civil society, academia, and industry. They're responsible for making scientific opinions that are then used by the European Commission and EU member states when deciding how chemical risks need to be controlled. Today, we'll be looking at the committee's opinions on harmonized classification and labeling proposals, applications for authorization, and restrictions. We'll also be looking at the Risk Assessment Committee's plan for developing guidance on the use of human biomonitoring in applications for authorization. More about that later. Let's start with the restriction proposed on Declarane Plus and its constituents. Now here, the Risk Assessment Committee adopted its opinion, while the Socio-Economic Analysis Committee agreed on its draft opinion at this stage in the process. This proposal comes from Norway and aims to ban this very persistent and bioaccumulative substance that is mainly used as a flame retardant, for example in motor vehicles and aircrafts. Tim, could you talk us through the Risk Assessment Committee's opinion?
Okay, thanks for the question. Just to backtrack a little bit, this is indeed about a very persistent, very bioaccumulative substance which stays in the environment for a very, very long time. And the ban is intended to prevent further stocks building up in the environment of this particular chemical. What we were primarily looking at is its use in articles or parts of articles. Usually these would be plastic parts, but not exclusively. And they need flame retardants in them to prevent them easily going on fire. So if there is a fire situation, these particular parts will be slowed down or prevented from combusting, which adds to everybody's safety in confined spaces such as vehicles. There are many, many flame retardants. So this is just one of possibly hundreds of substances or groups of substances which could be used. But this is one of a very large family of chlorinated or brominated flame retardants which have quite similar persistent characteristics and which as a group are a concern, not just this one.
And what did the committee conclude?
RAC agreed on the ban, but if you agree a ban, then you also have to look at situations where the substance may be needed for the future and try and allow some uses provided that the risk is controlled while banning all the rest. And these are called derogations. And industry requested several derogations, mainly for spare parts. So that would mean that after the ban, then spare parts which have already been produced up to a certain date can continue to be used. And one of those requests was for machinery, I think for garden, forest, and marine purposes. And the committee found this term, as did the forum, by the way, just too vague to be able to base a derogation on. It came with no supporting information as to the release of Declarane Plus that would accompanying it. And therefore, the environment would just not be protected by allowing this derogation. So RAC needs risk or emission-based information to support any derogation. And we were unable to recommend granting in this case. We did recommend one for use in hospital medical instrumentation for spare parts there, as we saw this as being a fairly narrow use, which would limit the risks when these things are recycled. Because it's very easy to be captured by the immediate uses of these substance in everyday products. But at the end of life of those products, they go to waste. And that's when the problems start, when we have to assess where and how these substances leach out of the products over time and contaminate the environment further.
Okay, now just to pick on what you said about alternatives existing for this substance. So you mentioned that there are many hundreds of similar substances, many though also with unwanted properties. But is it then correct to say that some are viable for the uses we're talking about here?
Yes, I think it would be very difficult to support a ban if there were no alternatives, because fire prevention and flame retardants is really a very essential use in modern society. So a restriction always looks to be sure that alternatives exist, and in this case they do. I think my point was more about undesirable alternatives. If you have so many substances which have properties like Declarane Plus, then it's relatively simple to pick one and use it as what we call a drop-in substitute. So we just get rid of one and we put in something very like it, but we don't solve the problem because we create a similar problem. And that's the issue with drop-in substitution. And in actual fact, this has already happened. We understand from market information that Declarane Plus was being used as a substitute for Deca BDE, which was banned some years back, also as a flame retardant, also similar type of chlorination, halogenation, and you can see this process happening then. So hopefully this time the move will be towards more acceptable in an environmental sense type of substitute.
Very interesting indeed. Now, before we move on to you, Maria, thank you also for joining the podcast and talk about the same restriction that we just covered with Tim, but from the socio-economic analysis perspective, where the committee agreed on its draft opinion. Could you explain a little bit first about the committee and what it does?
Yes, so I'm Maria Ottati, and I am the chair of the Committee for Socio-Economic Analysis. As the title of the name of the committee indicates, we look at the socioeconomic impact. So if we restrict this substance, then what would happen? What would be the impacts? What would be the costs to society of doing so? And what would be the benefits as well? And particularly, we also look at the analysis of alternatives just to see are there any actually alternatives that are available to be used for the substance? And if so, are they available to be used immediately? Would they need some time to be implemented? That obviously impacts on the costs that would be there for society of the restriction. And then, in addition to looking at the cost and the benefits, in order to make a decision, the member states need to, and the Commission need to consider the proportionality of the proposal, whether the benefits are worth the cost, basically. So, in some cases, SEAC can give some advice on the proportionality, but in some cases, we provide the decision makers the elements so that they're able to make that decision themselves. And that is the case in this substance, which is something that I think is pretty interesting. So in these cases, it's not possible to quantify the benefits. So in these cases, what the dossier submitter tends to do, and by dossier submitter, we call the member state that prepare the restriction proposal. So what they do is look at what we call cost effectiveness. So basically, how much would it cost to reduce 1 kilo of the substance? That is something that they have calculated in this case. And SEAC, what it does is basically to assess whether the value that they have calculated for this is reliable, and this is something that can be used for the decision makers to make their decision. So what is the issue here is that it's not up to SEAC to decide whether it's worth paying X or Y amount to restrict, to reduce 1 kilo of the substance. That's something that the decision makers need to decide. It's about what value society places in this. So I think that this is quite interesting because it's a bit of a line between what is scientific advice, which is the role of SEAC, and what is something that is more political, which is the role of the Commission and member states. So with this one, what the committee has decided was that it's not possible to say whether the different restriction options are proportionate or not, because obviously we have only the costs and not the benefits. So we only can tell you how much it would cost to reduce 1 kilo of the substance. And the other thing that SEAC has done is to look at the difference between the different restriction options. So basically dossier submits, in this case, Norway, they have looked at 3 different restriction options. One that has no derogations at all for any uses, one that has some derogations, and one that has similar derogations, but a little bit longer for some uses. And the idea is that the decision makers will have to choose between each of these 3, or maybe even they'll go to something in the middle. So what we have tried to do is to provide them some analysis of what it means to go from one restriction option to another. So yes, you can look at the overall cost per kilo of the emissions reduced by that particular option, but what does it cost to reduce 1 extra kilo from moving from one restriction option to the other one? We think this is something that is very important for the decision makers to consider, and it wasn't something that was in the dossier. So there has been some additional analysis that has been done by SEAC.
You mentioned that it's not possible to quantify the benefits in this case. Can you talk a little bit more about why?
So these are substances of concern simply due to the potential to remain and accumulate in the environment over very long periods. And the effects of such accumulation is very unpredictable in the long term. We don't know what the actual benefits are going to be. So we are not able to do what is done in other cases, which is to say, okay, these are the reductions in the endpoints, and therefore these are the benefits, and this is the monetary value of the benefits so that we can compare. So SEAC actually has a paper that gives recommendations about how we're going to be evaluating restriction reports and also applications for authorization for these kinds of substances. And this is published. And this says that cost effectiveness needs to be the basis from the framework, rather than the more classic cost benefits analysis, where you're able to quantify both sides of the equation and have a better idea of what the balance is.
Now let's move back to you, Tim. So could you walk us through the harmonized classification and labeling proposals that were on the agenda? And before you do, just for our listeners, so harmonized classification and labeling is when chemicals are given a consistent and mandatory hazard classification and labeling requirement within the EU. So this is particularly important for chemicals that can harm us or the environment. Go ahead, Tim.
Well, there's a whole range of things there, ranging from relatively small usage substances to absolutely massive ones. The ones I would like to highlight are 3. One is something called multi-walled carbon nanotubes. I'll explain that in a minute. The other one is sulfur, common everyday element, which many people will know. And I think those 2 illustrate what classification and labeling is all about in a way. So if I could go to the multi-walled carbon tubes or nanotubes, these are basically tubular graphite. You'd know graphite from the end of a pencil, for example. And these are tiny, tiny little tubes made of carbon atoms in the graphite crystal format. They're asbestos-like substances, and that should say something to many people. Asbestos is a well-known building material and a very potent cause of cancer, carcinogen. Now, these little fibers, they range from 1/3 millionth to 1/3 thousandth of a millimeter. So they are really, really tiny little fibers. They're what we call biopersistent. In other words, biological systems like, for example, our lungs, if you breathe them in, cannot degrade them. They stay there and they irritate the cells of the lungs. And they're actually small enough to actually be in or through individual cells, if you can imagine. They're extremely tiny. So they don't dissolve easily in the lung. They're quite rigid, so they form a solid surface against which the cell moves, and the cells are irritated, and that causes inflammation, and persistent inflammation can lead to through various processes to tumor formation and on the way to cancer.
And which cancer classification is then proposed for this one?
So in classification terms, carcinogenicity 1B is proposed. And the citation for that is presumed to have carcinogenic potential for humans. Classification is, and I put in myself, normally largely based on animal evidence. So because these carbon nanotubes are not actually asbestos, we don't have human data on them. We do have data from animal testing on them. And that's what the 1B indicates. If we had human data, it could possibly be 1A, which is the highest classification. And that's a known human carcinogen.
Okay, now you mentioned asbestos-like, so is it correct to assume that it's being used in construction mostly and mostly by workers, or are there other uses as well?
It's got extremely wide uses in construction and in all sorts of modern materials. It's also, I think, still very much being researched for new uses. That illustrates the importance of this classification. We know that this substance is quite potent in causing tumors, so it's as potent as some of the asbestos forms, for example, crocodolite, which is a well-known form of asbestos. So there's an absolute cause for concern and a very good reason for classifying this substance. And this should help to improve the safety of workers dealing with these sorts of materials.
Let's then move on to sulfur. Can you tell us a bit more about this one?
Yeah, this is maybe a somewhat unusual one. I mean, most people would know yellow solid sulfur from their local garden center because it's used as a common fungicide for spraying on your ornamental plants in your garden. Or if you've been in a volcanic area near a volcano or a hot vent, you would see the yellow staining of solid sulfur where steam is coming up out of the ground. But its use as a fungicide is extremely widespread. There's a lot of it produced, so it's a very high volume product. Now, it's not hugely of concern, but because its volume is so high, we have to be sure that people working with it and the public are adequately protected by the warning signs on the labels of the packaging. And that's part of what classification and labeling is all about. The label gives you the hazard warning and the hazard statements as to what we're aware of with the product. The main hazard is to the eyes, so either through irritation or in a worst case through corrosion where the cornea is actually damaged. And I mean, I think that's a fairly obvious hazard that people need to be warned of. It already has a classification for skin irritation, as you might expect. The other hazard which we looked at is something called specific target organ toxicity, single exposure. There's also a specific target organ toxicity repeat exposure. This one is single exposure. And that means specific or non-lethal toxicity to organs like the liver, the kidney, blood, and many other organs arising from one single dose of the chemical or one single exposure to the chemical. And it's an example of an acute effect which we want to prevent against. And this classification will warn people to be careful that swallowing this or breathing it in could cause damage to organs.
And ultimately, this classification will then help professionals using this substance in the field, but then also consumers using it in their own gardens.
I think it's important to realize that we take no account of the use of the substance. So even though I've been talking about the uses to give you an idea of what these substances do, we don't actually look at that at all. And we don't take account of the risks either that the use might pose. We're only interested in whether what we call the intrinsic properties of the substance fit the CLP criteria. And the legislation has a long set of criteria for all of these hazard classes that we've been discussing this morning. And likewise, we don't take any account of what people would see as downstream consequences. So if you get a classification in CLP, it usually has a knock-on effect in other dependent legislation further down the line. We deliberately ignore that to get a proper hazard evaluation. And CLP is an interesting piece of legislation in that it's horizontal legislation and it has connections maybe to 20 or more other pieces of legislation where the classifications have their real impact, and that's usually in the management of risks.
Let's then talk about the next steps for these proposals.
What happens to all of them is that the classifications we propose in our opinions are added to what's called an adaptation to progress, and it's basically an amendment to the legislation for consideration by the EU member states in the meeting for competent authorities for REACH and CLP, and that's the nickname of that is Caracal. So usually we would send every year about 50 opinions at a time, maybe more in some years. And once the proposed decision of the Commission has been agreed, then these substances are added to Annex 6 of the CLP. And normally they would have then entry into force 2 years after that. It's quite a long process, but it moves along in actual fact quicker than you might think. And it's fairly effective at identifying the really dangerous chemicals. And I think that's its main purpose, and providing warnings to everybody else about their dangers.
Now, before we move ahead, there were also 2 OELs, so occupational exposure limits, discussed in the RAC. So these are limits for protecting workers, essentially. Can you tell me more about those?
A couple of substances that we classified some years back. These are industrial chemicals. One is called isoprene, and the other is called 1,4-dioxane. It's a solvent. They were placed on Annex 6 of the CLP, and when that was noted, the Commission then requested ECHA and RAC to propose and then agree on occupational exposure limits to protect workers from these substances in the workplace. And what an occupational exposure limit will do is it will place a maximum limit that workers can be exposed to these substances in any workplace across Europe for their protection. So the national enforcement authorities would need to examine some of these workplaces and to check that the occupational exposure limits are being adhered to. And these are not indicative, these are binding occupational exposure limits. They go through a different process than CLP, so it will take a while for these to get to legislation and onto the annex of their directive. But at least it's good to see the connections between pieces of legislation, seeing progress as they interact together.
Okay, then moving on to you, Maria. Now, the Committee for Socio-Economic Analysis has decided to set up a working group on qualitative assessment. Can you tell us what will the group do and how will it benefit the work of the committee?
Yeah, so SEAC has in the past had situations where, at least in part of the proposals, there was quite a lot of reliance on a qualitative assessment of benefits or cost or proportionality. We had quite a big restriction recently where that was the case, where there wasn't a lot of data that would allow to quantify. That was BFHXA, which was basically a PFAS-related restriction. And that can be quite challenging to the committee. And there's a little bit of differences between the different members about how far we can go when that is the case. So what we like to do in those situations is to take the issue a little bit out of the assessment of a particular proposal and deal with it in a horizontal manner. So the idea is that we will set up a working group, which is basically made up of some of the members. So 4 to 6 members is what we are deciding. And that this group will come up with an approach that SEAC can take for this. So they will, first of all, identify under which conditions qualitative assessments are justified. So, I mean, the idea here is that we don't want every single proposal now to be qualitative. If it's possible to quantify, we want the dossier submitted to do so, and if it's proportionate, of course, to quantify. But then when we have cases where it's justified to provide a qualitative assessment, the group will identify some key principles and elements that a qualitative assessment would actually need to cover to enable SEAC to form an opinion. So it's there are different ways of doing qualitative assessment. It needs to be basically systematic and do things in a particular way. And we will try to set those out. So first of all, for the committee to be able to make its assessment, to have a position on what it's possible to do, but then also to inform the people who are preparing restriction proposals so that they know what the committee is going to need, and they're able to then make sure that they do things in a way that is not going to create trouble later on in terms of when the committee is assessing the proposals. Of course, they can choose not to take that into account. They're always free to do their analysis in whatever way they would like, but this is a way where if they follow the advice of SEAC, they are almost guaranteed that the assessment will go much more smoothly when it gets to the committee.
Before we continue, can you just, for the benefit of our listeners, explain what we mean by qualitative versus quantitative assessment in this context?
Yeah, quantitative is when we're able to put numbers on things, basically how many cases of cancer are we preventing, how many kilos of emissions are we preventing, what will be the actual costs to society of doing something, or even how many patients will not be treated if we ban a substance, that kind of thing. So we're able to put some numbers on things. Qualitative is when we're not able to do that. So we are able to describe the impacts and maybe give a little bit of information about whether we expect them to be big or not. But we're not able to put any numbers on them. When I say we, I mean the dossier submitter in this case, not the committee.
All right, thanks for clarifying. Now, I understood that this trend of qualitative assessments is expected to continue and even increase, particularly for proposals that cover a wide range of substances, sectors, or uses. Can you tell me why in those cases in particular?
Basically, there's more difficulty in getting data in those cases, particularly when it's very wide. It's an issue of workload for the team making the proposal. Of course, it's very difficult to do a full assessment of each and every single sector. And it may be that in some of them, the information is just not available. And looking at the cases that we have had in the past, we've identified that these are the types of cases where we tend to find this situation. So knowing that there are a few that are coming up in the future that are a little bit like that, and I'm thinking there of the universal PFAS restriction, for instance, which is coming early next year. I think we need to be prepared and think about this early and think about it with a little bit of time rather than try to do this more deep thinking alongside the assessment at what's what's expected to be quite a challenging restriction.
I have one more question for you. So what about the applications for authorization that were discussed by the committee? Anything you want to share with us?
Well, we've agreed quite a few opinions on applications for authorization, but it's not something I can say much about at this point. At this point, we will be sending those to the applicants so that they can comment. But I can tell you a little bit about one that was agreed in the previous plenary in December. That one has been sent to the applicants already, and they decided not to comment. So this one is done now, and I can tell you a little bit about that. So this is Caspar Walter, a company that is doing plating with chromium trioxide of cylinders that are used in it's called the rotogravure printing and embossing industry. So we're talking about here about printing commercially things like magazines, postcards, product packaging, all sorts of things like that. So in this case, the applicant is the manufacturer of the equipment, but they applied, yes, for formulation, but also for the use of the substance by its 117 downstream users. So this is what we call an upstream application. Rather than it being the user of the products that is applying, it's someone who is a little bit one step ahead of above of them, basically in the production chain. This is a lot more efficient than getting, for instance, in this case, applications for authorization from every single one of the 117 downstream users. So this was a very good example. In the past, we've had a lot of trouble assessing these kinds of upstream applications. The information that was contained did not really allowed to very good assessment. There was some doubts about whether for instance, the situation in terms of alternatives was the same for all the different subsectors that we were talking about within the application. But this was quite a nice example because there was quite a lot of homogeneity between the different users. So it was a very narrow use, and the information was actually gathered from the downstream users in a very systematic way, and it was analyzed as well very nicely in a way that provided the committee enough information to conclude. And also, since the applicant is the supplier of the plating equipment, the range of the different operational conditions and the different risk management measures that had been applied at the downstream users was also pretty homogeneous. So we could apply as committees, and this is the case for RAC and SEAC, some very clear and appropriate minimum standards. So in this case, SEAC is recommending a 12-year review period, which was what was requested by the applicant. We have also put this as an opinion, sorry, not the opinion, which is in the process of being published, not yet. But the actual application can be found on our website already and can be looked at. And it's actually been included. We've got a section of the website that gives some good examples that can be used by other applicants, and we've included that there.
So a very good example of how an upstream application should be done then. Thanks a lot for that. Then moving back to you, Tim. So the committee has recently been talking about developing guidance on human biomonitoring. To get us started, can you explain what human biomonitoring is?
Biomonitoring is the practice of taking samples from humans in the workplace to assess what kind of chemicals they've been exposed to. Now, it's a broader term than just workplace monitoring and exposure. You can biomonitor human beings literally in any situation. And a lot of the substances we deal with, for example, some of the metals like Chrome-6, cobalt, they have background concentrations in the environment, and we are exposed to these substances on a daily basis. So we always have a background. And biomonitoring is the practice of looking at the differences between background in various areas, and from people doing various things, eating various things, and behaving in certain familiar ways. For workplace biomonitoring, this becomes very important because it's a way of back-checking quite definitively whether a worker has been exposed to something that they really shouldn't have been exposed to. It's relatively controversial, as you could imagine, in that it involves workers giving consent to be biomonitored in the first place, being given assurances that the information they provide won't be misused against them, for example. So it's something that has to be very carefully thought through before, for example, we would recommend it in a regulatory sense.
All right, and I guess this is where the guidance comes in. So can you tell me, how is it going to help the committee?
Now, the context of this guidance is in applications for authorization, so granting authorizations or licenses for specific workplaces to use substances of very high concern. And the substance that we're considering more specifically here is chromium-6. We have been going through applications for authorization for Chrome-6 for at least 5 years now. We have a lot of experience of doing this in the meantime. We come across in countries like Germany and Italy regularly programs where the employers are monitoring their workers under national or local legislation. So we see these data sets and for specific companies, and they're very often part of the application. Most often they're reported as confidential to protect the workers' rights, but there would be a statement that the occupational physician monitoring the workforce has seen no exceedance of a particular reference level for that country. So we know that there's information there. Up to date, all we've done in our opinions is to recommend that they continue to do that, just in case something changes, they're inclined to stop. because we see it as beneficial for both the workers and for understanding what they're exposed to. But so far, we've been reluctant to recommend it across the board because it's extremely difficult for us to predict what the potential response will be. Maybe it's not possible in some countries. Maybe there's a lot of preparation needed before you can set this up. So,
okay, and have you ever requested for biomonitoring in the work of the committee in the past?
We've only ever requested it in authorizations where we really had high concerns that something was going wrong, and with certain substances as well. Diarsenic trioxide is one example. There weren't many applications, but those that we did get, we were particularly concerned about. Another one is a substance called MOCA, which is used in, if I'm correct, in manufacturing elastomers, so elastic polymers, for various industrial purposes. And that's a substance where we also had very high concerns about, so we recommended biomonitoring. But in general, we have not done so. So now we're reconsidering what our guidance for the future should be. And all of these issues will have to come into the discussion as we go forward.
So is it correct to say that through this work, we'll end up with a further measure to help improve worker safety in those cases where authorizations are granted? And this would be a measure that will also be legally binding.
Authorization decisions are indeed legally binding, and they contain detailed conditions with which the holder has to comply. So that's clear. As a result, we have to be very sure that any conditions we recommend really contribute to protecting workers and are not just nice to have or getting in the way. They have to be practical and enforceable. I would hope that at the end of this, we will have a contribution at least as to how biomonitoring fits in these workplaces and how far you should go to get the best protection for workers.
All right, and with that, we are at the end of our episode today. Thank you so much to both you, Maria, and Tim, for this deeper look into the work of the committees. For our listeners, if you want to know more about the two committees or the topics discussed in the episode, you can find those on our website. Remember to subscribe to the podcast at echa.europa.eu/podcasts. Safer Chemicals Podcast. Sound science on harmful chemicals.